Hi, everyone. Thank you for joining the webinar, Stop Hitting the Data Snooze Bar with Molecula's Cloud Data Access Platform. My name is Mimi Spear. I'm the Chief Strategy and Marketing Officer, and I'm here with Ganesh, who is our Chief Revenue Officer, and Matt, who is our Director of Engineering. So thank you so much for joining today. I know many of you are working from home and these are pretty crazy times. So we really appreciate you taking time out of your day to spend with us. And we hope that we can distract you from some of the crazy times and hopefully amaze you with some pretty groundbreaking technology. So hopefully you all are healthy and we hope to get past all this craziness soon. So in the next 45 minutes, this is just a quick agenda. We're going to go through kind of the opportunity and challenge around data access. We want to introduce, many of you might be new to Molecula, so we want to introduce you to Molecula, tell you a little bit about our customers and why some other approaches are not working today. We're going to get into some of the Molecula magic and the technical detail around Molecula, and then we're going to show you, hopefully amaze you with a demo, really even on the command line to show you some incredibly fast queries, crazy joins, and continuous analysis. So, and then we'll leave Q&A to the end. So those of you who have questions, feel free to put them in the chat, or we can open it up to Q&A at the end. So let's get started. Molecula's mission is to unlock human potential through the power of data. And we want to do this through data access. We want to make it easier for organizations to get the data that they want to help them innovate in their business and in their industry. And we believe that data access is going to be the way that we can all leverage data and really innovate easier. But why can't we do that today? We've all been trying this for many years. I know I've been in the data business for many, many years, trying to reach that threshold of innovation using data, but it's been really difficult. And we believe that we've really reached a tipping point in data access specifically, where the effort involved in making data accessible is far exceeding the value created with the data. On the business side, the data analysts and data scientists want to monetize the data. They want to be able to do real-time decisions and do real-time analysis and targeted campaigns. They want to be able to do the machine learning and AI that all these sophisticated technologies are able to do in a cost-efficient way. But it's incredibly difficult because there is so much data. And on the data engineering side, they're struggling, unfortunately, because of the amount of data. So much of the data is put into data lakes and Hadoop technology that makes it incredibly latent, and data gravity is a huge issue. They're spending so much time creating OLAP cubes and doing pre-aggregations and preparing the data to just make it easier to analyze. And the result of that is 1% of data today is accessible to the business, according to McKinsey. 122% of growth in data engineering jobs compared to data science, which really proves it's just difficult to deal with all of this data. Every project that is, created to, pulled out of a data lake, creating a new cube or a star schema or whatever data, analytic data lake that's created can cost up to 2 to 3 million in infrastructure costs. And the result of all of that is 15% of data is original today. So every time the business requests data and needs it in a certain format, the data engineers are forced today to create a copy of that data to get it in the right format for businesses to be able to actually analyze. And this is not secure, this is highly costly, and it really is not a way to scale. So just looking at this in an architecture, what's happening on the left side where data is coming in, we've really perfected that. There's fantastic technologies that are creating, data lakes like, Databricks and Snowflakes and other, technology like that, creating one persistent data store coming, with all of your data coming in from all the different sources. That is a great approach. The real problem exists in the middle, where data access, where we're taking that data from our persistent store and we're aggregating it, we're caching it, we're batching it to deliver it to the business, whether it's the data science organization, the business intelligence or analyst organization, or even, through self-source catalogs. So on the right-hand side, there's fantastic technology available to be able to consume the data. It's just being, it's just taking a very long time to be able to get it there. And the result is 80% of AI projects and ML projects are failing. It is a 4 to 6 week process to get the data to the consumption side. And again, there are 6 copies between data and decision. So let's introduce an alternative approach to this. So this is Molecula, and Molecula is a novel approach to data access. It is based on a mathematical, highly performant data representation that eliminates the need to pre-aggregate, federate, copy, cache, move the source data itself, or that persistent data store. So for data engineers and the data organization that has the responsibility of the infrastructure of that data, it is drastically simplifying their big data infrastructure with no compromise. They're able to provide access to 100% of the data in a much more simplified entity-specific schema, which is what Molecula is. And they do not need to pre-aggregate or pre-process that data ahead of time, nor do they have to move, copy, or cache the data. So it's a completely new way to be able to share data to the business. For the business, they are able to accelerate time from data to decision. Because of this new data format, they are instantly able to get the data and continuously do analysis or ad hoc analysis and deeper insights on that data. And because of this simplified, efficient format of the data, which by the way, it isn't actually the data itself, it's a mathematical representation of the data. Because of that, it is a much more efficient way to analyze data, and therefore we're getting a performance of starting at 1,000 times faster. So it's mind-boggling the exponential performance we are getting using the consistent tools on the other side. So your data science tools, your BI tools, whatever tool you're typically using, you can use on the consumption side, but with Molecula there to access the data, you're able to get that performance level. This reduces data cycle times, it eliminates data gravity, or at least minimizes it. And because we can join at query time versus pre-aggregating, we're drastically eliminating the time to take to integrate disparate data sets. CISOs love this because of the data format. It is a much more controlled way to grant access to data and share it in a more secure across your ecosystem, from edge to core to multi-cloud. You're able to apply your compliance requirements much easier, and you're reducing data sprawl. And because this is a representation of the data and not the data itself, we're actually reducing the actual data footprint from 10 to 100x. So your network costs and your infrastructure costs drastically go down. So let me show you how Molecula works. Again, on the left side, you've got all sorts of data coming from different places. It can be structured, unstructured, streaming data. You can either from there create your, what we're calling virtual data sources in Molecula, or you put it in that one persistent data lake or data store. From there, we have plugins that ingest the data. We put it in virtual data sources by entity. And this is where you get your lossless compression of 10 to 100x as that abstraction is occurring. So you get the, the upside on the network as well as the infrastructure costs at that point. And then on the consumption side, using the typical tools that you use or your custom applications or through your data catalog, you're consuming this data starting at 1,000x performance. So we're going to show you some examples of 12-hour queries going down to sub-millisecond timing. So let's talk about some use cases that are ideal for Molecula. Molecula is ideal for a very large query, very large data set, so massive data sets, fast and complex queries, many distributed data sets. So if you've got data, we are not going to be able to have our data in one place anymore. We have to accept that data will be everywhere, in every cloud, at the edge, on-prem. And so how can you optimize for that situation? And then we're going to want to always be, or many use cases require streaming data with historical data. Today, in the large query and fast queries, Today, the cycle times and queries take too long, so organizations are kind of forced to build cubes, and this is what still takes time to build those cubes, and it's not the ideal way to do that. When you're talking about distributed data sets or combining streaming with historical data, today it requires a lot of pre-aggregation and pre-processing, and so many organizations are building analytic data lakes to do that. So let's talk about some use cases that are ideal for Molecula. The number one use case today with our customers is dynamic segmentation. The ability to get a 360 view of your customers and really be able to ask any question about your customers in real time. And this is, the key is actually as data comes in about your customers and their behaviors, you can then target them. You can then, provide them a more personalized experience. Another big one for Molecula is migration to the cloud for analysis. Many organizations are struggling which data to migrate, how they want to take sensitive data and then migrate that to the cloud in a cost-efficient way and not costing too much. Well, because of the data format and because we're not actually moving that data itself, but more of a mathematical representation of the data, Molecula is ideal for migration to the cloud. And because you're getting that lossless compression, you actually save on your network costs, moving it to the representation to the cloud, and that infrastructure or the cloud costs ultimately. So it's a great option for that. And then IoT is another one I just want to call out. Because IoT typically requires the combination of, analyzing data across many, many devices and many locations, and that's very simple kind of streaming data with the historical data about that device and even additional transactional data that's going on that is relying on that device, Molecula is very good for that type of use case as well. So now I want to pass it to Ganesh, and he's going to talk about our customers and some use cases and how they're using Molecula.
Thank you, Mimi, and hope everybody is staying safe and washing your hands. Glad to be here, and thank you for joining the call. So as Mimi said, we truly believe that we have a very revolutionary technology here, a core capability that was first developed back in 2017 as an open source project called Pilosa. And Pilosa was, it still is the open data format that allows the representation of any source, any type of data in this highly performant, schema simplified representation that can make analysis really fast and real time. And since we started in 2017, we have a pretty strong community of about 2,000 organizations, several large Fortune or Global 2000 organizations that use and leverage and driving a lot of innovative projects with Pilosa. What we also noticed in the process was, operationalizing the Pilosa open source data format. These organizations had all the horsepower to go do it. They had backend developers, they had data engineers who would actually write code, DevOps engineers who would actually integrate into multiple pieces. And that gave us that was the number one pain point they were actually facing. Even though the core technology was so powerful, the operationalizing it at enterprise scale required a lot of effort, which is what we actually built the Molecula Enterprise last year for. So Molecula Enterprise was launched in May of 2019, and we've seen some amazing uptake and interest from customers. We have about 10 new enterprise customers since that time, and with at least 3 Fortune 500 companies. Some of the logos you see, some of them you don't. They're all using it, and the underlying thing is they are all using Molecula to increase their or decrease their time from data to decisions, and fundamentally changing the way they run their data operations to make instant real-time decisions from all available data. Can you move to the next slide, Mimi? So let me tell you a few of the success stories that we have seen so far. And some of them are very unique, but these are challenges that are faced by organizations and enterprises of any scale, right? I mean, and like, for example, the technology infrastructure company that leverages Molecula to go drive customer support personalization. It all started for that company about 5 to 6 years ago when they made a very big strategic decision to make sure they insert telemetry in all of the software and hardware components that get shipped out of that company, in all the customer environments, and they were collecting this large data sets. In addition, they had a pretty thriving business with customer growth happening year over year. They had all these warranties and claims, and you'll see a little bit of that represented, that kind of an example through our demo later in the call, later in the webinar. So what they were actually trying to do is they had three distinct problems. One, with the large amounts of data that resides in multiple systems, the time it took to make decisions on that data. A BI report to be populated required about 12 hours of runtime for an OLAP cube to be populated, do multiple joins and integration and aggregation logic to make that happen. And then it'll be published to the business to go do their analysis. And then comes the second problem when the executives want to go deep dive and understand something more granular that's not pre-populated in the data. That added another 2 to 3 week cycle for them to get that data, integrate it again, and make it available. And all this was taxing the data operations team, where they were actually really working off a small team with all this large growing data set, and it was impossible to manage. What Molecula enabled for them, the ability, so the solution there is the ability to actually integrate in real time across all of these data sets by creating this VDSs, or virtual representations of that data, so that pre-processing and aggregation logic are massively minimized. Data to decision cycles are now not hours anymore, but in less than a second, with the ability to do real-time joins across these massive data sets. And furthermore, they're now being able to use a very efficient infrastructure because of the compression that you see with Molecula. Excuse me. Because the compression that you see with Molecula to be able to take the telemetry data, which is in the order of 2 to 3 terabytes a day. This actually grows. And to be able to represent that without having to spin up about 10 to 20,000 CPU cores to pre-process and then make it available. And they're now able to turn that entire experience into a real-time decision-making engine, further powering this business. And the use cases they're working on with the ability, with this newfound superpower to be able to deal with large amounts of data, is personalize the customer support experience. When a customer calls into tech support and they're about to ask about a particular problem, the tech support personnel already has the data that is residing, or the decisions, the knowledge that is residing within the telemetry data, within multiple customer support systems, ready, available for them to make a very informed decision, reducing the average call times. What they're also working on is to be able to deliver this experience directly to consumers through their web interface for support, for technical support, through the chat forums and so forth. Another example is this large media company who is using Molecula to do content and experience personalization at scale. So this is a large media company, multiple different business units, multiple different data sets, everything from theme parks that is actually generating IoT sensor data on the mobility and movement of individuals and visitors in the park, to online data that is actually encompassing the online and digital experience of visitors and customers. And they were trying to do real-time segmentation to understand different segments of these customers, to personalize and to target advertising, to target different messages and content too. And as you can imagine, in a large organization with this amount of variety of data, it is always really difficult. So there was a lot of pre-processing that was happening to put all that data into a data lake and then do the manual aggregation and pre-processing logic to make it ready for analysis. And after it's actually done, they would run those queries on that data lake, which would take hours to get one of their longest segmentation queries done. And then furthermore, again, when you want to deep dive and dive deeper into doing this in real time, that becomes almost impossible to go to. What Molecula enabled for them was we layered on top of their data lake for their customer data platform. And we actually created this virtual entities, or entity-centric virtual data sources, or VDSs, of all the relevant entities, customers, visits, events, online digital campaigns, theme park visit, theme park IDs, and so forth. And we were able to deliver them an experience where their longest segmentation query, which used to take hours, will now run in just seconds, with the ability to actually do this joins across multiple historic and streaming data sets, which was a huge issue. Most organizations take the streaming data set, put it into an object store, and then run science and machine learning on it to combine it with historical data. They were able to now do that in real time by looking at clickstream and using the intelligence that is actually available in those VDSs across all of the digital and non-digital data sets to do real-time personalization of content and experiences. The third example is Q2 Banking. Q2 Banking is a fintech company who is focused. They power about 10% of all the regional and local banks in all of North America. And what they do is actually provide the service where they do login fraud and monitoring, threat monitoring for bank logins. So the time when you actually type in and go into, let's say, an example, austinfederalcreditunion.com, you're usually hitting Q2 banking servers where they do the processing to make sure that you're a legitimate login, you're actually not a bad actor or a data aggregator like Wealthfront or so forth. And then they pass on to the actual bank. And they're now working very closely with the banks to do further value adds to those individual regional and local banks. What they were struggling with was the ability to actually look at real-time login information to detect fraud based on signatures that happen in the historic data. And if you really think about what they were doing, and most organizations do it this way, they would take the real-time data that's coming in, they will put that into an object store, they will then further pre-aggregate and process it to create a unified view across that real-time data and the historic data that is historically there, train their machine learning models, and then put it in production. And what this does is actually the nature of bad actors and login attacks that happen, these signatures change almost instantaneously in a matter of hours. This whole process to get the data out, put into a particular location, and then do the science and then deploy the models in production was just not feasible. They were not able to scale with that. So what Molecula unlocked for them was the ability to actually merge the real-time data as well as the historic data in a single analytical plane so they can look at segmentation of events based on certain characteristics they have in the past to make real-time decisions on whether, hey, this login is actually a real person that is trying to log in, or this is a signature of a bad actor, or furthermore, things like Wealthfront or mint.com, which is a data aggregator. So end of the day, we enabled a much lower infrastructure cost for them to maintain this environment, because now they're able to provision logins for the right kind of users and not having to over provision just to accommodate that surge in mint.com or Wealthfront logins that happens. So these are some of the examples from our customer set. If we go to the next slide, Mimi. One of the things that we see, we fundamentally believe that the future of enterprises will have a future of hybrid data that is sitting in multiple locations, multiple geographies, multiple devices in multiple formats, right? And what it really becomes impossible, all of the approaches today has been about trying to get an aggregate and put all the data in one place before you can do anything. But the ability to actually do that in a way that is real time is just escaping everybody who's trying to do it. What we can enable with Molecula is a real-time distributed data access platform across clouds and from cloud to edge. The ability to actually do real-time queries, real-time joins on, when you're sending a query that actually requires it to go analyze data in multiple locations, multiple clouds, multiple devices, to do that in real time, to be able to, have a standard format, when we are moving more and more towards a simplified schema format, the ability to actually have this deconstructed view of entities, customers, devices, projects, warranties, claims, orders, all of those different things across the enterprise, irrespective of where the data is residing, gives the ultimate ability for enterprises to make real-time decisions with all available data. And lastly, the portability of this data, where you can now make decisions like leave the data that is very critical and sensitive on-prem, but move your modern analytical workload onto a cloud, and the best cloud that is possible. Then if that doesn't work, just move it to another cloud without having to do data mobility or actual moving of that data. So these are some of the absolute value that we unlock for enterprises, and we're really anticipating a lot of our customers going into this future where they see it's now possible, which was not before, to use Molecula to unlock data anywhere, anytime, to make real-time decisions. With that, let me just pass on to my friend, Matt Jaffe, the Director of Engineering.
Hey, thanks, Ganesh. Hello, everyone. Can you go to the next slide, maybe? Technology detail. All right. So we've made quite a few bold claims here, and I just kind of want to try to give the technical perspective on why these, why you should, believe these at all. And so the first thing I'm going to do is give this sort of architectural overview of what is inside Molecula. And so the first thing that's highlighted here is the VDS. And a VDS is kind of akin to a database table. So your VDSs are like your different data objects that you're dealing with. And it's a little bit more general than a database table in that there's some simplification and schema collapsing that you can do due to some of the features of the data representation, which I'll get into. And the next thing, if we can, yes, the VDSM. So the VDSM is the component of Molecula that basically is the management and API layer for queries. So the VDSM enables a variety of kind of the ways to look at your data. It has some security pieces, and it's basically the component that runs and is the API to your VDSs and your infrastructure and everything that goes on in Molecula. The next piece is Pelosa. So we run an enterprise version of Pelosa inside Molecula, and this is sort of the workhorse of data processing and query processing, and of course the data representation that kind of makes everything happen. And then finally, we sort of have a rich plugin ecosystem to extend Molecula. And this is, we can go to the next slide actually. This is both on the ingest side, on the query side, and sort of operationally different monitoring plugins, all kinds of different ways to extend Molecula's functionality to get it to work with the tools you already have or the tools you're already using. One more slide. Okay, so let's get into the core data representation. And so first, a very small history lesson. Back in the 60s, 70s, 80s, the original relational databases were developed, right? So that's this image on the left here. And they stored data in the most obvious way, right? You store it record by record, row by row. So if you have data about a person, you kind of store all that data about that person together. And if you want to fetch data about that person, it's all in one place, you can get that data. What we soon realized was that while some use cases that worked very well, other use cases, mainly analytical use cases where you were trying to look at sort of broad queries across the data, gathering statistics about the data, there was a different data format that worked better, and that's the columnar database. And the key idea behind a columnar database is that you store data column by column rather than record by record. So where previously you might have had all the data about a single person in one place, now you have all the data about people's ages in one place. So everyone's ages are stored together, and in another column, in another place, you might have all the data about genders in one place, and so on. And this allows you to do a couple different things. Kind of at the low level, it means that when you're doing a query, you only have to interact with the columns that you care about. So you end up scanning a lot less data for many queries. And since input-output, I/O, is one of the big drivers of performance, this means that because you can scan a lot less data, you can query much faster. The other thing it does, which is a little more subtle, is that you're now storing like data with like. So if you have a bunch of ages in one column, you're storing them all together. That's very similar data, which is all stored together which lends itself nicely to compression. So if you do things carefully, you can get a lot of compression by storing data in a columnar form rather than a relational form. What we believe we've done at Molecula is taken this idea to its logical extreme. And instead of breaking the data out column by column, we actually break it out value by value within each column. And then each value within each column is actually represented as a compressed bitmap, where each bit represents whether a particular record has a particular value. And so when you're doing a query, you not only don't have to scan data for columns you're not interested in, you don't even have to scan data for values you're not interested in. So this can decrease the amount of I/O you need to do by another order of magnitude or more, depending on the query. You also get follow-on compression benefits similar to what we got going from relational to columnar, but even more so because now you're storing all data in essentially the same way. You're representing it all as compressed bitmaps. Can we go to the next slide, Mimi? Thank you. So this enables a whole host of different things, which we're still even kind of discovering and realizing all the different capabilities that storing data in this way gives you. But I think the first thing, the most important thing, and probably two things actually, we have breaking the latency floor, and then on the right side, high concurrency analytics. And these two things are pretty closely related. And so what this is when you store data in sort of a standard representation, like a relational database, you can always scale out, right? That's what technologies like Hadoop do for you. They allow you to scale out and add more and more hardware to be able to process that data in a reasonable amount of time. But the more you scale out, the higher your latency floor becomes, the lowest possible achievable latency, because you have to fan these queries out to so many more hosts. There are physical limitations around how quickly you can do that, and how many servers you can fit into a small enough space. So by having a more concise data representation that actually allows you to look at less data and do less processing, we can lower the effective latency floor dramatically, which gets you into going from use cases where you're having to sort of run queries one by one and analyze things, wait for the query to finish. Now you can sort of run queries in real time and interact with a UI rather than sort of interacting in a sort of a much slower iteration speed. And so once you can do that, once you can have things run at UI speed and you can keep people engaged, you can also open these things up to much wider audiences, right? It's no longer just a single analyst building a report, that takes a week or something. You can open this thing up to your entire marketing department or your entire company or even all your customers. And you can sort of open up analytics to everyone. And that's what this high concurrency analytics bullet point is talking about on the right. This is not just, doing single query analysis. You can have many people doing analytics at the same time and having them all interacting with it. The other things that this data format opens up are things like portability. I mentioned compression. When you go from relational to columnar, you get some benefits of compression. When you go from columnar to this vector format, you actually get even more compression, so much so that we found that it's often a 10x reduction in data size. And so that allows you to move data around a lot more. You can play a lot of tricks with sort of where you're doing this transformation to reduce your bandwidth costs. There's many efficiencies to be gained here. Another thing this lets you do is control. And what I mean by control is you have very granular access to which parts of the data you're sharing and which parts you're not, because it's all broken out at such a detailed level. We're not just breaking things out by table or by column, but we're actually breaking them out value by value. And each value is stored as what the value actually is. Maybe its shirt color is green, right? So that is stored separately from which records have that value. And so if you just have some kind of machine learning job that you want to do, maybe you don't need to share the actual values with that job. Maybe you just need to share the bitmaps that represent which records have those values. So there's this sort of very granular access to data that you can give that's very difficult to do with a lot of other solutions. The last thing which I touched on is the schema simplification. It turns out that when you represent data this way, you get some things for free. You get the ability to have multi-valued fields essentially for free. So, previously where you might have had 2 tables or 3 tables to essentially put multiple values into one field, now you can sort of collapse that all down into a single VDS. Okay, let me jump into the demo and then we'll kind of come back and finish up. So, yeah, I can do this slide first. That's good. So here, this is kind of the overall architecture of the demo. We've got data. This is all generated data, by the way, but it's very similar to use cases that we've encountered with our customers. So we've got data on the left coming from multiple different sources. We have maybe some marketing type data in Cassandra. We've got various customer data in Teradata, and then we've got data about claims and purchases in MySQL. And these are potentially coming from many different departments of a large enterprise. What we do is we ingest these disparate data sources into Molecula and represent them as VDSs. So we kind of have broken down in the middle these entity-specific VDSs. So we have one that just has a lot of marketing data, and then we have them kind of broken out by items. These are like individual items that people have purchased, customers have purchased. We have customers, which could be individuals or companies. We have warranties, which are actual warranties taken out on individual items or groups of items. And we have claims, which are when a claim is filed on a warranty. And then on the right side, of course, there's all these different ways that people might ingest or use this data. Next slide. So just a quick overview of what the raw data size looks like, and then what the data size looks like when it's ingested into a VDS. And you can see it varies a little bit, but it's always a pretty extreme decrease in size. And on the left, we have the number of records per VDS. There's 1.5 billion items that have been purchased by 100 million different customers. There's 2.1 billion different warranties. So in some cases, these items might be like laptops or something where you can get a separate warranty on the battery versus the whole machine or the hard drive or whatever. So there's actually more warranties than items. And then there's 50 million claims. And then there's 1 billion records in the marketing data set. Okay. So there's many different things one might do with this data. And I'll go through some quick scenarios in the demo, but these are some example use cases of how this data might be used in an enterprise, whether that's trying to understand what customers are buying and when, versus trying to understand what your exposure is in terms of warranties and claims, and looking at past history of claims versus claims that are actually coming in now, and trying to understand and predict what kind of exposure you have in the future to that kind of thing. Okay, can I take the screen from you, Mimi?
Absolutely. I'm stopping sharing so that you can jump into this demo. And I just wanted to, let everyone know we're going to jump into a quick demo so you can see the magic for real and see how it works. And then we'll wrap up with some Q&A and a little bit just about why other approaches don't work now that you actually see this in action.
Okay. Can everybody see this terminal window? Does that look like it's going to be big enough?
Yes. Yes. It's full screen.
Awesome. Okay. So the first thing I'm going to do is I'm going to connect to Molecula's VDSM with the PostgreSQL client tool. So this is the standard PostgreSQL client tool that you get when you install Postgres on a Linux machine. But I'm connecting to Molecula's VDSM. So in this case, the client tool has no idea that it's connecting to Molecula, but Molecula is effectively able to act as though it were Postgres. So here I'm connected, and the first thing I'm going to do is just turn on timing so that we can see how long these queries are taking. And I'm just going to interact with a couple of these VDSs today. So the first thing we'll do is just take a look at customers. You can see each customer has a region they're from, a sales channel, and some size. And as we discussed before, there are 100 million customers. Now, one interesting thing that you should note here immediately is that this select star limit 1 query actually took longer than counting the entire data set. And that is a byproduct of the data representation. This select star is not the type of query you want to use Molecula for. There's hundreds of different database solutions out there that are good at that. This is the kind of analytical thing that you want to use Molecula for, that it's absolutely amazing at. And that is the essential trade-off of this data representation. So let's just do really quickly, let's look at regions for these customers. So this is grouping by region and then ordering by the number of customers in each region. And you can see that's like ridiculously performant across 100 million customers. And I'll just show you one more thing. Because we are kind of in control of what's going on the back end, we can actually send the subset of SQL that we support over this channel, or we can send our own query language that Pelosa natively supports, which is PQL. And we can send them both through this standard PostgreSQL client. So here's the same query we just did, but in PQL. Next, I want to take a look. So that's customers. There's 100 million customers. Let's take a look at items. So there's 1.5 billion and 1 items. And items looks like this. So each item has a cost, a customer ID that purchased that item, a product line, a product type, and a ship date. And just for example, we can do that same ordered group by on product lines. And you can see there's a few at the top there that are like real names, and then just a bunch of generated product line names to kind of fill out the data set. So let's do things a little bit more, something a little bit more interesting. So we can take this query, which is grouping by region and sales channel on the customers table, and also summing the size of those customers. So it's a group by with an aggregation. And you can see that's still pretty quick. And I limited that to 100 rows of output. But so you can start to see, you can probably start to think of use cases where you can really explore this data set. Let's get even more interesting. Let's do a query which is effectively a join across customers and items. So in this case, I want to get the number of customers from the US who have purchased an item which is in product line 3094. So I have to deal with the items VDS and the customers VDS here. Remember, there's 1.5 billion.
Quick question. How long, will you just comment a little bit on how long this might take in another system, just to kind of compare?
Yeah, I mean, if you just kind of dump this data into, say, MySQL without really thinking about it too much, these queries would take hours. If you added indexes and tuned things very carefully, you might get down to minutes.
Thanks, Matt.
Yeah. So let's run this one. So in 600 milliseconds, we're able to do that count, across those billions of records. And just as a final query, we'll take that same kind of join, but we'll embed it in a group by. So now we're grouping by region and sales channel, but we only want to see customers that have purchased that item, an item from that product line, and we're still doing that aggregation, so summing across the size of the customers. So now we can see our customers that have purchased that item broken down by region and sales channel with the number of customers in each group and the sum of their sizes. So that's all I have on the command line side. I will give it back to you, Mimi.
Me? Yeah. Excellent. Okay, thank you, everyone. We're going to wrap this up. I know I said 45 minutes, and we're just a couple minutes over that. I just have one more slide, really, and that is, so you learned about Molecula, you learned about one of the big problems of today. We just want to summarize to you why some of these other approaches do not work. And they all are, there's some great approaches out there and great technology, but when it comes to very large data sets, joining across multiple data sets in different locations, complex queries and analysis, we believe that this new abstraction technique is the best. With query federation, you're actually querying at the source data. So you're bogging down the source data, and this fundamentally does not scale. When you've kind of run out of options in the query federation because you're not scaling, many organizations pull the data out and create data lakes, or data marts and our OLAP cubes. And this requires pre-aggregation, pre-query. It requires, a lot of pre-processing work to be done in order to actually do the analysis. So again, this is not, for the future of real time or the future of massive amount of data that you want an automated system that you can actually analyze as data comes in. And then many organizations, as that doesn't work, really pushes brute force. And this is taking, GPU or, really strong hardware and pushing hardware to make things faster, which is fine, but it's incredibly expensive and it does not scale over time. So you only can do it for your most valuable queries. So we believe that this new mathematical abstraction approach, that you're not actually taking all your data, but you're making this incredibly efficient format for data, is really the future. And we'd love for you to learn more about Molecula. Just as a summary, we have the performance of this is beyond anything we really have ever experienced before. You heard Matt's excitement about it. And we believe that also you're taking the security level to a new level as well. And then most importantly, this is going to drastically simplify and reduce the cost of all of your infrastructure. So now I want to go to Q&A and open it up to some questions and answers. I do see that there is some questions and answers, so I'm going to go ahead and stop sharing and read the questions and answers. So first of all, one of the questions is, do you have to give up a bunch of your infrastructure? Or do you have to start over with what you currently have? And the answer is absolutely not. You don't have to start over. You can put this alongside your existing environment. Now, will this allow you to simplify your architecture and reduce and get rid of other inefficient databases or data lakes and data cubes that are being used specifically for analytics? Yes, you can do that. And over time, we believe you can eliminate all 6 copies between data and decision. So will this reduce costs, reduce the amount of technology that you have to buy? Yes, but over time, we don't want to be at the beginning, we don't want to be disruptive into your environment. So could you talk about pricing and licensing models? So the way that we price is subscription pricing. It's per virtual data source, and we sell a t-shirt size packages of virtual data sources. Most organizations get started with 10, and every package includes 1 virtual data source manager. So let's see. Looks like this can actually be quite effective for financial and healthcare use cases. Could you talk more about that? Ganesh, do you want to answer some of the questions about the different industries and use cases that are good for this technology?
Absolutely, absolutely. I think there's 2 things, right? This as Mimi said, initially discussed in the webinar, the the power of Molecula is most realized when you have large disparate data sets and you're looking across those data sets to make real-time or near real-time decisions, right? So in financial services, we've actually encountered a few different kind of common threads or common use cases. One is on the front end, like retail banking, commercial banking side, where you're going in and trying to understand your customers or your institutions. We are working with some asset managers who are actually looking at institutional customers as well. And there's multiple data points with respect to all of them. And they're trying to actually do some real-time analysis on it to either power a personalized experience in most cases, or just understanding the segments in a lot more detail in a dynamic fashion. The other side of financial services, we are also working with some asset managers, one of the world's largest asset managers, who is looking at how do we most effectively share data across multiple constituents. When they create these materialized views of data where they're merging and integrating multiple things, sharing becomes a huge concern. One is the cost in actually moving the data, and also the security and the control reasons of actually not wanting to move the data across geographies or across different institutions. So they use the VDS as a way to share governed data sets, if you will, on financial services. So those are some common use cases, very much around segmentation, and then we're seeing that data then being transferred or made mobile without actually moving or copying the data. On the healthcare side, we're actually seeing a variety of different use cases. On the life sciences and the pharma side, we're doing everything from just basic enterprise, speeding up their BI reporting and dashboards to more specific things like digital pathology. So there was a question around images and metadata. So if you have pathology images or radiology images, those can be the metadata. Most of these organizations apply machine learning to do feature extraction from those images. And that metadata, that features are then indexed into a VDS. And then you now have a very portable data format, and then can be joined across customer data, demographics data, real world data, genetic data, and so forth to go make it happen. On the provider side, we are also, it's mostly segmentation, population health kind of use cases, patient health, physician assistance use cases, if you will, to look at, again, data about a particular entity, be it customers, patients, organizations, or products, and then integrating that data or having an integrated view of the data without having to do the pre-processing and aggregation across all of those elements. So those are some examples.
Great, thank you, Ganesh. And we have one more question. I think we'll give this one to Matt if you're still on. It looks like the technology would be quite effective. Oh no, sorry, you talked about data aggregation in the discussion. How about aggregating across different formats, such as imaging and metadata? So Matt, you want to take that one?
Yeah, for sure. So there's a couple different things to unpack here. You can certainly take data from different sources and put them into VDSs or into a single VDS even. But what you have to understand is that the data does need to be structured. There's currently no way to just take an image and put it into Molecula. For sort of unstructured data, there does have to be some kind of pre-processing step to either do feature extraction or whatever it is to get it into some kind of a standardized schema, to be able to query and analyze. So on the one hand, yes, you can take data from as many sources as you want and add new fields or add to existing fields within the same VDS and kind of have that data in one place. But on the other hand, you can't just take a big blob of text or like a huge pile of documents or images or videos and expect to be able to do anything with them without some amount of pre-processing or feature extraction to sort of make that data queryable, if you will.
Excellent. So I think that wraps it up. If there are no other questions, then we really appreciate everyone joining during these difficult times. Please stay healthy, hang in there. We're going to get through this. If you have any questions about Molecula, please contact us on our website. We have a great white paper to download that gives you even more detailed information. And we would love to answer any questions or chat with you about your specific use cases.